Today we are going to discuss about square and triangular waves. Square wave, AC quantity whose magnitude remains constant with respect to time in positive as well as negative half of cycle for same duration is known as square wave. Now, as we are having different parameter associated with sine wave, similarly we are having parameters associated with different square wave as well. For example, instantaneous value, average value, effective value, peak factor, form factor, and peak to peak value. Instantaneous value means the value of the quantity at any instant t. Let it is t1, it is t2, and so on, t3. Average value, the average of this function over the period for half cycle, similarly for another half cycle. Effective value or RMS value, the quantity from one for this quantity equivalent to DC. Then peak factor, that is given by peak value and RMS value. Form factor, which is given by RMS value and average value. Now, by the definition, in case of square wave, here it can be observed that if we are considering average value of this quantity for the half cycle, and half cycle here it is 0 to pi. For 0 to pi, the average peak value is Im. The average of 0 to pi will be again Im, and hence average value and peak value for square wave is same. Similarly, when we are considering effective value, RMS value, the peak value and RMS value will remain same. IRMS is equal to Im. Peak factor is the ratio of peak value to the RMS value, and hence it will be unity. Whereas the form factor is the ratio of RMS value to average value, which is also unity. The peak to peak value for this cycle, if it is Im, here it will be minus Im, then peak to peak value will be 2 Im. Whereas in case of AC quantity, these parameters we have found out by using the mathematical function or taking the area under the curve. Now, considering the triangular wave is also a AC quantity whose magnitude changes linearly from its zero to maximum and vice versa. Here there are three representations of triangular wave. The first representation shows that from 0 to pi this function is varying and having a maximum value at pi by 2, whereas the triangular wave is taken as 0 to 2 pi, whereas the maximum value is at pi. Now the third function is again 0 to 2 pi, whereas the maximum value is at 2 pi. This is maximum. Now, considering these three different representations of triangular wave, their peak value, RMS value, form factor, average value, and etc. can be analyzed. Now, considering the first waveform, considering this waveform, this function can be defined as the slope of this line. What are the slope of this line? 0 to pi by 2. The slope will be negative, but having same magnitude from from pi by 2 to pi. And here we can say the slope of this line is maximum value is Im, that is y2 minus y1 divided by x2 minus x1 into t, or here it is function is theta, let it is theta. Y is maximum value is Im, the minimum value is 0. Along y axis we are taking from up to pi by 2 minus 0 into theta, and hence slope for 0 to pi by 2 will be given by this function. Similarly, for the pi by 2 to pi by 2 is less than theta is less than pi, this part 2 Im is added. If we are putting the value of pi at any instant, then we can find out the value of it. Why we added here 2 Im? It depends upon the function, and this function is mathematically satisfied when 2 Im is added in this in this quantity for the complete cycle, as far as first waveform is concerned. Now for the second waveform, in second waveform the function varies from 0 to 2 pi, and whatever the slope is 0 to pi, the same slope will be pi to 2 pi, and hence if we can take from 0 to pi, then we can analyze from pi to 2 pi. Here we are considering from 0 to pi, the function is Im minus 0 upon pi minus 0, because x2 is pi and x1 is 0 into my theta. When we are analyzing from pi less than theta is less than 2 pi, then this function will be 2 im is added in this function. Considering the third waveform, in third waveform the complete cycle is between 0 to 2 pi, and hence if we can analyze this function, then it will be automatically analyzed for the next cycle. Now considering this, then here maximum value is applying the same concept. Maximum value is im, minimum value is 0, 2 pi minus 0 into my theta, and this function gives the magnitude from 0 to 2 pi. Whereas these two functions are, it gives from 0 to pi, it gives from 0 to 2 pi but divided in two parts. This is also 0 to pi but divided in two parts, because there are two slopes. One slope is this, another slope is this. Similarly, in this case, one slope is this, another slope is this. Whereas in this case, there is only single slope varying from 0 to 2 pi. That's why third function we need not to add 2 pi in this case. It is satisfied with this function only. Now, considering the average value, since we are knowing the magnitude of the quantity, this is the magnitude of the quantity in this case, in first 0 to pi by 2, and this is the magnitude when considering 0 pi by 2 to pi, and hence this function is separately integrated from 0 to pi and then pi by 2 to pi, and these two values, putting the value of this it function for different these two parts, this is for first half, this is for second half, and solving this integration function, the final value will be im by 2. Similarly, we are getting average value of the second waveform. In case of second waveform, putting the value of it from 0 to pi and then pi to 2 pi, and integrating this whole function will give the average value as im by 2 pi, im by pi. Whereas when we are considering third waveform, in third frame we are having only single function which varies from 0 to 2 pi. Integrating this function from 0 to 2 pi, the average value will be im by 2 pi. So im by 2 only. Now to find out RMS value, RMS value is nothing but the special case of average value. If we are squaring these functions and taking the under root this quantity, then it will become RMS value. Squaring this function, first function, similarly squaring the second function and taking the under root of the whole quantity, then it will be RMS value. It on simplifying this quantity, mathematically simplification, the resultant value will be im by root 3. Similarly, for second waveform, squaring this function, squaring the second function, and putting all these limits and taking under root of this whole quantity, the resultant value will be im by root 3. The third function is taken as taking the square of the third function, then integrating from 0 to 2 pi, that is the limit, and then squaring root of this function, the resultant value will be im by root 3. In this case, since we know the peak factor is by the definition is peak value upon RMS value, and that is peak value is im, RMS value is IRMS, im divided by im by root 3. The peak factor for this triangular wave is root 3, whereas for the sine wave it was root 2, whereas for square wave it was 1. The form factor by the definition is RMS upon average value. Putting the value of RMS and average, RMS value is im by root 3, average value is im by 2. The form factor for triangular wave is 1.115, whereas for sine wave it was 1.1, sine wave it was 1.11, square wave it was 1, whereas triangular wave it is 1.15. For all these three waveforms, we can analyze this form factor, peak factor, RMS value, average value, and instantaneous value. For sine wave, instantaneous value is defined by as a sine of function, whereas rectangular or square wave, instantaneous value and peak value remain same. In case of triangular wave, the instantaneous value is defined by taking the slope of the line, depending upon the limit 0 to pi, pi to 2 pi, or 0 to 2 pi.